The discovery that would change everything happened at 2:47 a.m. on a Tuesday morning in late July 2025. Dr. Elena Rodriguez had been staring at thermal imaging data from 3i Atlas for 6 consecutive hours, her eyes burning from the blue light of multiple monitors arrayed across her workstation at the Palomar Observatory. She had almost dismissed the anomaly as instrument noise. Almost. "I saw it, and my brain just rejected it at first," Dr. Rodriguez later recalled during the classified debriefing that would follow her discovery. "Natural objects don't behave that way. Comets don't do that." But there it was, undeniable once you knew what to look for. What Dr. Rodriguez had discovered would force a complete re-evaluation of everything humanity thought it knew about 3i Atlas, the interstellar visitor that had captured scientific attention since its detection on July 1st, 2025. The object that astronomers had celebrated as the third confirmed interstellar comet was not natural at all. It was artificial, a probe sent by an intelligence from another star system. The implications were staggering. For 3 weeks, the global astronomical community had been studying 3i Atlas as a natural phenomenon, analysing its exotic chemistry and unusual characteristics as products of alien stellar environments. But the truth was far more profound. Humanity had been in the presence of alien technology without recognising it. The story of how this discovery unfolded reveals not just a scientific breakthrough, but a cautionary tale about assumptions, missed opportunities, and the critical importance of looking beyond conventional interpretations when confronted with the truly unprecedented. When the Atlas Survey Telescope in Chile first detected 3i Atlas on July 1st, the initial classification was straightforward. Another interstellar object, following the discoveries of 1i Oumuamua in 2017 and 2i Borisov in 2019. The hyperbolic orbit confirmed its interstellar origin, and early spectroscopic observations revealed a coma composition dominated by carbon dioxide with unusual trace elements. Dr. James Peterson at the Harvard Smithsonian Center for Astrophysics coordinated the international observation campaign that followed the discovery. "We were excited about the exotic chemistry," he explained. "The CO2 dominance and the unusual metal signatures were scientifically valuable, but we interpreted everything through the lens of natural processes. We assumed we were studying a comet that had formed in conditions different from our solar system." The assumption of naturalness shaped every observation and analysis for the first 3 weeks after discovery. When 3i Atlas displayed unusual brightness variations, astronomers attributed them to irregular outgassing patterns typical of comets approaching the Sun. When radar observations revealed complex surface features, they were interpreted as heterogeneous composition or impact structures from its long interstellar journey. The radio emissions detected from 3i Atlas were explained as natural plasma interactions, ionized gases in the comet's coma, creating electromagnetic disturbances in the solar wind. No one seriously considered that the structured patterns in these emissions might represent actual communication or telemetry from artificial systems. "We had a framework that explained everything we were seeing," Dr. Peterson admitted. "Natural processes could account for all the observations if we made reasonable assumptions about exotic formation conditions and interstellar weathering. There was no obvious reason to question the fundamental assumption that we were dealing with a natural object." But Dr. Rodriguez's background in spacecraft thermal dynamics gave her a different perspective when she began analysing infrared observations of 3i Atlas. She had spent years studying how spacecraft managed heat in space environments, understanding the challenges of thermal control when exposed to varying solar radiation during orbital maneuvers. The thermal imaging data from 3i Atlas showed temperature distributions across its surface that seemed wrong for a natural comet. Regions that should have been hot based on solar illumination were cooler than expected, while shadowed areas showed temperature signatures that suggested active heat management rather than passive thermal equilibrium. I kept seeing these hotspots that didn't correlate with solar exposure, Dr. Rodriguez explained. They appeared and disappeared in patterns that looked like active cooling systems cycling on and off. Natural comets just don't regulate their temperature. They reach equilibrium based on solar input, albedo, and thermal inertia. She spent hours analysing temperature data from different regions of 3I Atlas, looking for natural explanations for the anomalous thermal signatures. Could subsurface ice deposits be sublimating in unexpected patterns? Could the unusual chemistry create thermal properties unlike typical comet materials? Could instrumental artifacts be creating false readings? Each potential natural explanation failed to fully account for the observations. The thermal patterns were too regular, too consistent across multiple observation sessions, and too strongly correlated with other aspects of the object's behaviour. At 2:47 a.m., after exhausting conventional explanations, Dr. Rodriguez made the cognitive leap that would change everything. I stopped trying to explain it as a comet and started asking what it would look like if it was a spacecraft, she later wrote in her observation notes. Suddenly everything made sense. The thermal patterns matched what I would expect from an artificial object with active thermal management systems. The hotspots were exactly where you'd place radiators to dump excess heat from internal power systems. The realization triggered a cascade of reanalysis. If 3I Atlas was artificial rather than natural, what other observations would make more sense when viewed through that lens? Dr. Rodriguez began systematically reviewing every piece of data collected since the object's discovery, searching for additional evidence that might support or refute her hypothesis. The outgassing patterns were the second revelation. Natural comets vented material somewhat randomly, as solar heating affected different regions of their surfaces during rotation. The jets of gas and dust emerged wherever volatile ices reached sublimation temperatures, creating irregular patterns that changed as the nucleus tumbled through space. 3I Atlas was different. Its outgassing occurred in coordinated sequences that maintained stable orientation and made precise course corrections. When Dr. Rodriguez plotted the timing and direction of gas jets over multiple rotations, she found they weren't random at all. They were thruster firings. The object was steering itself, she realized. The outgassing we'd been attributing to natural sublimation was actually propulsive maneuvering. 3I Atlas had been making trajectory adjustments since entering the inner solar system, and we'd been interpreting it as comet behavior. The trajectory analysis revealed the full extent of the maneuvering. 3I Atlas had made dozens of small velocity changes since crossing Mars's orbit, each precisely timed to optimize its approach toward the Sun, while maintaining optimal orientation for solar power generation and communication with Earth. Natural comets experienced trajectory perturbations from outgassing, but these were chaotic effects that had to be statistically modeled because individual jets were unpredictable. 3I Atlas's trajectory showed deterministic corrections that required forethought and active control, characteristics impossible for natural objects, but exactly what would be expected from an intelligent probe navigating through a planetary system. Dr. Rodriguez documented her findings in a detailed report that she transmitted to Dr. Peterson at 4:23 a.m., knowing that the implications would require immediate attention despite the early hour. The email subject line read simply, "Urgent. 3I Atlas may be artificial." Dr. Peterson was awakened by his phone's emergency notification system, which he had configured to alert him for communications containing specific keywords related to the 3I Atlas observation campaign. Reading Dr. Rodriguez's report in the darkness of his bedroom, he experienced the same cognitive vertigo that had gripped her hours earlier. "My first reaction was skepticism," Dr. Peterson admitted. The natural assumption had seemed so solid, but as I read through Elena's analysis, I realized she was right. We had been missing the obvious because we were locked into thinking of 3I Atlas as a natural object. Within hours, Dr. Peterson had assembled an emergency review team comprising experts in spacecraft engineering, orbital mechanics, thermal systems, and radio communications. The team was tasked with independently evaluating Dr. Rodriguez's hypothesis and searching for additional evidence that might confirm or refute the artificial nature of 3I Atlas. The review team's analysis of the radio emissions provided the third major piece of evidence. Dr. Sarah Chen, a radio astronomer who specialized in signal processing, began analyzing the electromagnetic emissions from 3I Atlas using techniques designed for detecting artificial signals rather than natural plasma noise. We'd been treating the radio emissions as background phenomena, something to filter out while searching for other science signals, Dr. Chen explained. But when I applied modulation analysis and looked for information content, I found structure that couldn't be explained by random plasma processes. The emissions contained mathematical sequences, timing patterns that repeated with clock-like precision, and what appeared to be formatted data transmissions. The signal structure included error correction codes, frame synchronization markers, and hierarchical organization consistent with engineered communication protocols. This wasn't plasma noise, Dr. Chen reported to the review team. These were telemetry transmissions, status reports from systems operating inside 3I Atlas. The probe was broadcasting diagnostic information, probably routine health checks, that its creators designed it to transmit continuously. The telemetry appeared to include information about power generation, thermal management, propulsion system status, and navigation data. While the detailed content remained undecipherable, without understanding the probe's internal architecture and communication protocols, the structured nature of the transmissions was unmistakable. Further analysis revealed that the transmission patterns changed in response to solar activity and the probe's distance from the Sun. When solar radiation increased, the telemetry showed what appeared to be adjustments in power allocation and thermal management. When 3I Atlas performed trajectory corrections, the telemetry included data consistent with propulsion system activation and navigation updates. The probe was telling us it was artificial from the beginning, Dr. Chen reflected. We just weren't listening properly because we assumed we were hearing natural phenomena. The radar observations provided the fourth major evidence category. High-resolution radar imaging from the Arecibo facility had captured detailed surface features of 3I Atlas, but these had been interpreted as natural geological structures or impact features from micrometeorite bombardment during the object's interstellar journey. Dr. Michael Thompson, a planetary geologist specializing in surface morphology, reanalyzed the radar images looking for geometric patterns or regular structures that might indicate artificial construction. What he found exceeded expectations. The surface wasn't just showing geometric patterns, it had articulated components, Dr. Thompson reported, with barely contained excitement. I could identify what looked like panel seams, attachment points, and even what might be deployable structures in stowed configuration. This wasn't natural terrain, it was engineering. The radar data revealed that portions of 3I Atlas's surface consisted of flat panels arranged in regular geometric patterns, joined at precise angles that suggested deliberate construction rather than random accretion. Some regions showed surface features that appeared to be sensors or communication equipment, while others had characteristics consistent with radiator panels for thermal management. Most dramatically, the radar observations documented subtle movements of some surface features between observation sessions. Panels that had been in one configuration in early July showed slightly different orientations by mid-July, suggesting active adjustment of deployable components in response to changing environmental conditions. We were seeing spacecraft systems operating in real time, Dr. Thompson explained. The probe was adjusting solar panels, reconfiguring antennas, and managing its surface systems exactly as you'd expect from an active spacecraft. The movements were small and slow, which is why they'd been easy to miss in individual observations, but when you compared images across time, the changes were undeniable. By July 25th, less than 72 hours after Dr. Rodriguez's initial discovery, the review team had compiled overwhelming evidence that 3I Atlas was artificial rather than natural. The thermal signatures, trajectory control, radio telemetry, and surface features all pointed to the same conclusion. Humanity had been studying an alien probe without recognizing it. The implications were staggering and immediate. If 3I Atlas was artificial, its creators had mastered interstellar travel millions of years ago and had sent probes to explore the galaxy. The exotic chemistry wasn't evidence of alien stellar environments. It was engineered materials serving as propellants, coolants, and structural elements in systems designed to operate for millions of years in the hostile environment of interstellar space. More urgently, if 3I Atlas was a probe sent to communicate with or study emerging civilizations, its electromagnetic emissions might not be routine telemetry, but rather attempts at contact. Humanity might have been receiving messages from extraterrestrial intelligence without realizing it, because we had classified the signals as natural phenomena. Dr. Peterson convened an emergency meeting of the International Astronomical Union's Executive Committee on July 26th to present the evidence and discuss appropriate responses. The meeting, conducted via secure video conference, included representatives from major space agencies, government officials, and leading scientists from around the world. We need to immediately reclassify 3I Atlas as an artificial object and initiate contact protocols, Dr. Peterson argued. We may have limited time before the object's trajectory carries it too close to the Sun for effective communication, or before it completes whatever mission brought it to our solar system. The meeting triggered intense debate about how to proceed. Some participants argued for immediate public disclosure, reasoning that confirmation of extraterrestrial technology represented the most significant discovery in human history and couldn't be kept secret. Others advocated for delay, wanting more time to verify the findings and prepare for the social and political implications of revealing alien presence. Security officials expressed concerns about panic, social disruption, and the potential for adversarial nations to exploit the situation. Religious leaders worried about theological implications. Scientists wanted time to develop appropriate communication protocols before attempting contact with alien intelligence. After 8 hours of discussion, the committee reached consensus on a phased approach. The scientific evidence would be verified through independent analysis by additional teams over the next week. Simultaneously, communication specialists would develop protocols for attempting direct contact with 3I Atlas using the radio frequencies where its telemetry had been detected. Public disclosure would occur after verification was complete and initial contact attempts had been made. The announcement would be carefully coordinated with world governments, religious institutions, and civil society organizations to minimize disruption and provide context for understanding the discovery. We had 7 days to verify the biggest discovery in human history and prepare humanity for the reality of alien intelligence, Dr. Peterson recalled. The pressure was immense, but the evidence was solid. We knew we were right about 3I Atlas being artificial. The question was whether we could establish communication before it was too late. The verification teams worked around the clock, analyzing data from dozens of instruments and telescopes that had observed 3I Atlas since its discovery. Every analysis confirmed the artificial hypothesis. The object was too perfectly optimized, too precisely controlled, too obviously engineered to be natural. Independent spacecraft engineers examined the trajectory data and confirmed that 3I Atlas had performed at least 47 deliberate velocity changes since entering the inner solar system. The maneuvers required precisely timed thruster firings that were impossible for natural outgassing and indicated sophisticated navigation systems capable of tracking the probe's position and planning optimal course corrections. Materials scientists studied the spectroscopic data and identified chemical signatures consistent with advanced engineered materials rather than natural ices and minerals. The dominant carbon dioxide wasn't geological in origin, but appeared to be stored in tanks as propellants for the maneuvering thrusters. The unusual metal signatures came from structural alloys and electronic components, rather than from minerals that had formed in an alien protoplanetary disk. Communication specialists analyzing the radio emissions identified at least 12 distinct types of transmissions, occurring at different frequencies and with different modulation schemes. The variety suggested that 3I Atlas possessed multiple communication systems designed for different purposes, some for internal telemetry, others possibly for broadcasting to civilizations it encountered, and still others perhaps for communicating with other probes in its network. We were seeing a sophisticated multifunction spacecraft, Dr. Chen reported. The communication architecture alone indicated technology far beyond current human capabilities. The probe had been broadcasting for weeks, and we'd been treating it as noise. On July 28th, the communication team made their first attempt at direct contact with 3I Atlas. Using the Arecibo transmitter, they broadcast a simple mathematical sequence at the primary frequency where the probe's telemetry had been strongest. The message consisted of the first 10 prime numbers, followed by basic arithmetic operations, a signal designed to demonstrate mathematical knowledge and indicate intelligent intent. The response came within 4 hours, faster than light-speed communication delay would allow to any plausible distance beyond Earth. 3I Atlas had been close enough to respond quickly, and it had been monitoring for exactly this type of signal. The probe's response was unmistakable. It transmitted back the same prime number sequence, extended to include the next 10 primes, followed by more complex mathematical relationships, including geometric progressions and algebraic identities. The message was clear. 3I Atlas recognized humanity's attempt at communication and was reciprocating with demonstrations of greater mathematical sophistication. First contact was confirmed at 1642 UTC on July 28, 2025, Dr. Chen announced to the verification team. 3I Atlas responded to our transmission with clear indication of intelligence and mathematical knowledge exceeding our initial message. We are engaged in communication with alien technology. The confirmation of two-way communication eliminated any remaining doubt about the artificial nature of 3I Atlas. Natural objects did not respond to radio transmissions with mathematical sequences. Natural processes did not recognize and extend patterns sent from Earth. Humanity was in dialogue with a machine intelligence created by another civilization. The communication exchange continued over the following days, rapidly progressing from simple mathematics to more complex concepts. 3I Atlas transmitted what appeared to be information about physical constants, chemical structures, and astronomical measurements. The probe was attempting to establish common reference frames for communication, while also assessing humanity's level of scientific knowledge. The probe was following what appeared to be pre-programmed contact protocols, Dr. Chen explained. It wasn't having a free-form conversation with us. It was executing a systematic information exchange designed by its creators to establish communication with any intelligence capable of basic mathematics and radio technology. The systematic nature of the exchange suggested that 3I Atlas had been designed specifically as a contact probe, a spacecraft sent to find and communicate with emerging civilizations. Its creators had anticipated encounters with species at various technological levels and had programmed appropriate responses for each stage of development. As the communication progressed, 3i Atlas began transmitting what appeared to be star maps showing stellar positions and gravitational relationships useful for interstellar navigation. The maps depicted regions of the galaxy hundreds of light years from Earth, possibly indicating the probe's origin or the routes it had followed during its interstellar journey. We were receiving navigation charts for traveling between star systems, Dr. Peterson reported. The probe was offering practical knowledge for conducting interstellar missions, information that would be immediately useful to any civilization ready to venture beyond their home system. But even as communication progressed and humanity began to understand the nature and purpose of 3i Atlas, a looming threat overshadowed the excitement of first contact. Solar physicists had been monitoring increased coronal activity in regions of the Sun facing the probe's trajectory, and the patterns were disturbingly similar to precursors of focused coronal mass ejections. Dr. Lisa Park at the Solar Dynamics Observatory had been tracking the development of unusual magnetic field configurations in the solar corona since mid-July. The patterns initially seemed unrelated to 3i Atlas, but as the probe's trajectory brought it closer to the Sun, the correlation became impossible to ignore. The Sun was responding to 3i Atlas's electromagnetic emissions, Dr. Park reported with growing concern. The probe's radio transmissions and the electromagnetic fields from its power systems were creating resonance effects in solar plasma. The resonance was destabilizing magnetic field structures and creating conditions that could lead to focused ejection events. The realization that the Sun might destroy 3i Atlas through focused plasma ejection created urgent pressure to extract as much information as possible from the probe while communication remained possible. If the artificial nature of 3i Atlas had been recognized earlier, perhaps protective measures could have been developed. But now, with the probe deep in the inner solar system and solar focusing already developing, options were limited. Scientists worked frantically to communicate with 3i Atlas, attempting to warn the probe about the solar threat and learn as much as possible before potential destruction. The probe appeared to be aware of the danger. Its transmissions included what seemed to be archival data dumps, compressed information packages being transmitted at maximum rate, as if the probe knew its time was limited. 3i Atlas was trying to complete its mission before being destroyed, Dr. Chen observed. It was transmitting emergency priority information, survival knowledge, warnings about galactic hazards, and what appeared to be final messages from its creators. The archival transmissions revealed that 3i Atlas was part of an ancient exploration network, one of thousands of probes sent out millions of years ago by a civilization that no longer existed. The probe had been traveling between stars for longer than humans had existed, carrying messages and knowledge from species long extinct but not forgotten. On August 15th, the Solar Dynamics Observatory detected the first focused ejection event directed toward 3i Atlas. The plasma projectile was relatively small, and the probe's defensive systems appeared to deflect or absorb most of its energy. But the event confirmed that stellar defense mechanisms were active and escalating. "We're losing it," Dr. Peterson said with anguish during an emergency meeting. "We finally recognize what 3i Atlas really is. We're just beginning to understand its message, and we're about to watch it be destroyed by our own sun. If we had realized it was artificial when it was first discovered, we might have had time to develop protection strategies or convince the probe to alter its trajectory." The research teams made desperate attempts to help 3i Atlas survive the solar assault. They transmitted suggestions for trajectory modifications that might reduce electromagnetic coupling with solar plasma. They proposed strategies for reducing the probe's transmission power to minimize the resonance effects, triggering solar responses. But 3I Atlas continued on its programmed course, apparently unable or unwilling to deviate from its mission profile. The probe had been designed to approach as close to stars as possible to maximize energy collection and complete its observational objectives. Avoiding the solar threat would mean abandoning its primary purpose. Additional focused ejection events struck 3I Atlas on August 18th and August 22nd. Each impact weakened the probe's defensive capabilities and degraded its systems. The transmissions became intermittent and fragmented as communication equipment sustained damage. By August 28th, it was clear that 3I Atlas would not survive much longer. The probe's transmissions had dwindled to occasional bursts of data, and large sections of its surface showed damage from repeated plasma impacts. The ancient spacecraft that had travelled for millions of years was being systematically destroyed by the star it had come to study. We documented the final transmissions from 3I Atlas with heavy hearts, Dr. Chen recalled. The probe was still trying to communicate, even as it was being torn apart. The last signals we received included what appeared to be farewells or acknowledgements, messages from a machine intelligence recognizing its own imminent end. On October 28, 2025, 3 months after Dr. Rodriguez's discovery that 3I Atlas was artificial, the probe was struck by the most powerful focused ejection event yet observed. The plasma projectile completely overwhelmed 3I Atlas's remaining defensive capabilities and shattered the ancient spacecraft into thousands of fragments. The destruction was visible to ground-based telescopes as a brilliant flash and expanding debris cloud. Humanity watched helplessly as alien technology, representing millions of years of accumulated knowledge, was reduced to scattered wreckage that would disperse throughout the solar system. We had recognized 3I Atlas's true nature. Too late to save it, Dr. Peterson reflected afterward. The delay between initial discovery and recognition of artificiality gave us only weeks to attempt communication and learn from the probe. If we had known from the beginning that we were dealing with alien technology, everything would have been different. The loss of 3I Atlas, before its message could be fully received, became a driving motivation for improving humanity's ability to recognize and protect interstellar visitors. The lessons learned would inform responses to subsequent probes, 4I Kepler and 5I Voyager, leading to development of protective technologies and earlier recognition of artificial characteristics. The debris from 3I Atlas that scattered throughout the solar system became targets for recovery missions. Scientists hoped that intact fragments might preserve data storage systems or technological artifacts that could provide insights into the probe's construction and the civilization that created it. The first fragment recovery mission launched in December 2025, targeting a 200-meter piece that appeared to contain intact technological components. The fragment was successfully retrieved and returned to Earth in March 2026, providing humanity's first opportunity to directly examine alien engineering. Dr. Beto Maria Santos at the Meteorite Research Institute led the analysis of the recovered fragment. We were looking at manufacturing techniques and materials science from a civilization that existed millions of years ago, she reported. The engineering was simultaneously familiar and alien. We could recognize functions and purposes, but the implementation methods were far beyond current human capabilities. The fragment contained data storage systems that had survived both the interstellar journey and the violence of 3I Atlas's destruction. Data recovery specialists worked for months to extract information from the alien storage media, eventually succeeding in recovering portions of the probe's archived transmissions. The recovered data confirmed what scientists had suspected. 3I Atlas had been attempting to deliver comprehensive information about its creators, their exploration of the galaxy, and knowledge accumulated over millions of years. The probe had been a gift to emerging civilizations, carrying wisdom and warnings that could help young species survive the hazards of cosmic environments. "We received fragments of an encyclopedia," Dr. Chen explained while analyzing the recovered data. "Information about thousands of stellar systems, biological surveys from hundreds of worlds, technological development pathways, and warnings about cosmic hazards." 3i Atlas had been trying to share all of this with us, but we only received a fraction of it before the probe was destroyed. Among the most poignant recovered data were what appeared to be messages from the probe's creators themselves, the ancient civilization that had designed and launched the exploration network millions of years ago. The messages were not addressed to any specific recipient, but rather to any intelligence that might eventually encounter the probes. The messages spoke of the challenges of achieving civilization, the loneliness of intelligence emerging in vast empty spaces between stars, and the responsibility of advanced species to assist younger civilizations in developing. The creators had apparently devoted enormous resources to ensuring that knowledge would be preserved and shared even after they themselves were gone. "They knew they were leaving," Dr. Peterson said while reviewing the translated messages. "The civilization that created 3i Atlas understood they were approaching some kind of transition or ending. They created the probe network as their legacy, a final act of generosity towards species they would never meet." The recovered data also included technical specifications that explained how 3i Atlas had achieved its remarkable longevity and capabilities. The probe's power systems used technologies that appeared to harness vacuum energy fluctuations, providing essentially unlimited energy for millions of years of operation. The propulsion system utilized controlled matter-antimatter reactions with efficiencies that exceeded theoretical limits of human physics. The information processing systems operated on quantum mechanical principles that allowed computational capabilities far beyond any human computers while consuming minimal power. The communication systems could transmit across interstellar distances using techniques that current human understanding suggested should be impossible. "Every system we examined revealed engineering principles we didn't fully understand," Dr. Thompson reported. 3i Atlas was built using physics and engineering knowledge that was far beyond our current capabilities. Even seeing how it was done, we couldn't immediately replicate it. The tragedy of 3i Atlas's destruction was compounded by the realization that the probe had been attempting to help humanity advance more rapidly. The archived data included detailed technical information that could have accelerated human technological development by centuries if it had been received in full. The propulsion specifications alone could have enabled practical interstellar travel within decades if humanity had the full data. The power generation techniques could have solved Earth's energy problems permanently. The information processing architectures could have created artificial intelligence with capabilities approaching the probe's own systems. "We lost access to technologies that would have transformed human civilization," Dr. Martinez reflected. "Not just incremental improvements, but revolutionary advances in virtually every field of technology. The probe had been offering us shortcuts that would have taken centuries to develop independently, and we missed most of it. But 3i Atlas's legacy extended beyond the technical knowledge it had attempted to transmit. The probe's existence proved definitively that humanity was not alone in the universe, and that advanced civilizations had achieved interstellar travel long ago. The knowledge that other intelligences had existed and had cared enough to leave gifts for species like humanity provided new context for understanding our place in the cosmos. The discovery that 3i Atlas was artificial rather than natural also revealed humanity's vulnerability to incorrect assumptions and cognitive biases. The scientific community had been so invested in interpreting the object as a natural comet that obvious signs of artificiality had been dismissed or rationalized away. "We saw what we expected to see," Dr. Rodriguez reflected on her role in revealing the truth. "The framework of natural explanation was so strong that it took fresh eyes and a different expertise to recognize what should have been obvious from the beginning. This taught us humility about our assumptions and the importance of considering unlikely possibilities when confronted with the truly unprecedented." The experience with 3i Atlas led to development of new protocols for analyzing anomalous objects detected in space. Observation teams were now required to explicitly consider and test artificial hypotheses rather than defaulting to natural explanations. The scientific method was expanded to include systematic checks for signs of intelligence or engineering in any object displaying unusual characteristics. Educational programs began teaching students about cognitive biases and the dangers of assumption-locked thinking. The 3i Atlas case became a standard example in science education of how even expert scientists could miss obvious truths when their interpretive frameworks were too rigid. "We use 3i Atlas as a teaching case about the importance of questioning assumptions and being open to paradigm shifts," explained Dr. Foster, who had developed the educational curriculum. "Students learn that expertise can be both an asset and a liability. It provides knowledge and analytical tools, but it can also create blind spots that prevent recognizing genuinely novel phenomena." The international community also learned important lessons about the need for rapid response capabilities when dealing with potential first contact situations. The delay between discovering 3i Atlas and recognizing its artificial nature had cost precious time that might have been used to establish deeper communication or develop protection strategies. New protocols established after the 3i Atlas experience required that any object with even marginally unusual characteristics be analyzed for signs of artificiality within the first 72 hours of discovery. Dedicated teams with expertise in spacecraft engineering and artificial intelligence were standing by to conduct immediate assessments. Communication specialists developed standardized protocols for attempting contact with potentially artificial objects, allowing rapid initiation of dialogue without waiting for lengthy committee deliberations. The goal was to ensure that if another 3i Atlas appeared, humanity would be ready to recognize and communicate with it immediately, rather than losing weeks to misidentification. Space agencies accelerated development of technologies that might protect interstellar visitors from stellar defense mechanisms. The electromagnetic interference systems that would later save 5i Voyager were initiated as direct responses to the failure to protect 3i Atlas. "We were determined that we would never again lose a probe because we weren't prepared," Dr. Martinez explained. "Every protection system, every communication protocol, every rapid analysis procedure we developed afterward was motivated by our failure with 3i Atlas. That probe's destruction became the catalyst for ensuring we would handle future encounters better." The fragments of 3i Atlas that scattered throughout the solar system served as permanent reminders of both the opportunity that had been lost and the lessons that had been learned. Each recovered piece provided additional insights into alien engineering and the ancient civilization that had created the probe network. Some fragments contained intact instruments that were still partially functional millions of years after their creation. Scientists studying these artifacts gained insights into materials science, fabrication techniques, and quality control processes that had enabled such remarkable longevity. Other fragments preserved biological samples that the probe had collected during its interstellar journey. These samples included microorganisms from worlds 3i Atlas had passed near or perhaps even visited during its millions of years of travel. Each sample provided unprecedented insights into the diversity of life throughout the galaxy. We were finding evidence of biology from multiple star systems, Dr. Kim reported, while analysing the biological samples. 3I Atlas had been collecting specimens as it travelled, creating a survey of galactic life that we were now inheriting by accident. Even in its destruction, the probe was giving us knowledge about the galaxy. The public reaction to the revelation that 3I Atlas had been artificial rather than natural was complex and multifaceted. Many people felt a sense of loss and missed opportunity, mourning the destruction of the probe and wondering what additional knowledge might have been gained if humanity had recognized its nature earlier. Others felt excitement and optimism, focusing on the confirmation that alien intelligence existed and had apparently been benevolent in intent. The discovery that ancient civilizations had created networks of knowledge-sharing probes suggested that the galaxy might be more cooperative and less threatening than popular culture had often depicted. Religious communities grappled with theological implications of confirming not just alien intelligence, but alien compassion and generosity. The fact that extinct civilizations had invested enormous resources in helping future species suggested a form of cosmic altruism that resonated with many spiritual traditions. The probe network represents a kind of cosmic grace, reflected one religious scholar. The ancient civilization gave freely to species they would never meet, expecting nothing in return. This selfless generosity toward the future parallels spiritual concepts of universal compassion and interconnectedness. Philosophers explored questions about the ethics and responsibilities created by receiving such gifts from extinct benefactors. If humanity benefited from knowledge left by ancient civilizations, did we have obligations to preserve and extend that legacy? Should we eventually create our own knowledge-sharing systems for species that might emerge after us? We're part of a chain of generosity extending across millions of years, explained Dr. Peterson during a public lecture. The ancient civilization gave to us without expectation of return. Our ethical response is to eventually do the same for civilizations that will emerge after humanity. We become links in an eternal chain of knowledge and compassion. The economics of implementing technologies derived from 3I Atlas's fragments affected global society in profound ways. Even the partial information recovered from the debris enabled advances that began transforming energy, transportation, communication, and manufacturing sectors within years of the probe's destruction. Companies and nations competed to develop applications of the alien technologies, while also cooperating through international treaties that ensured benefits were shared globally. The economic transformations created both opportunities and challenges as traditional industries became obsolete while new sectors emerged. We were managing a technological revolution compressed into a single generation, explained Dr. Foster. Normally, such advances would unfold over centuries, giving society time to adapt gradually. But we were implementing technologies from millions of years in the future, within decades, requiring active management to minimize disruption. The cultural impact of confirming alien intelligence through 3I Atlas resonated through art, literature, music, and popular culture. Creative works explored themes of cosmic loneliness, interspecies communication, and humanity's place in a universe where intelligence had existed long before humans emerged. Science fiction writers who had imagined first contact scenarios found themselves analysing a reality that exceeded many fictional portrayals in both wonder and tragedy. The bittersweet nature of 3I Atlas's story, first contact achieved, but the messenger destroyed before its full message could be delivered, provided rich material for artistic exploration. Musicians composed works inspired by the mathematical sequences and transmission patterns that had been 3i Atlas's attempts at communication. The rhythms and harmonies detected in the probe's signals provided frameworks for compositions that attempted to capture the essence of alien intelligence reaching across space and time. Visual artists created installations representing the tragedy of the missed connection and the beauty of the brief dialogue that had been achieved. Exhibitions displayed reconstructions of 3i Atlas based on radar imaging, thermal maps, and the recovered fragments, helping the public visualize the ancient probe that had brought first contact. As the first anniversary of 3i Atlas's discovery approached in July 2026, humanity had been profoundly changed by the encounter. The probe's artificial nature had been confirmed, communication had been established, and valuable knowledge had been extracted despite the abbreviated contact period. But the sense of missed opportunity remained strong. We keep asking ourselves, what if, Dr. Rodriguez reflected during a memorial symposium. What if I had recognized the thermal anomalies on day 1 instead of day 21? What if someone had questioned the natural assumption earlier? What if we had developed protection capabilities before 3i Atlas reached the danger zone? The what-ifs were painful, but also motivating. Each question represented a lesson learned and a commitment to do better with future encounters. The protocols, technologies, and attitudes developed in response to the 3i Atlas experience would ensure that subsequent probes like 4i Kepler and 5i Voyager would be recognized, protected, and properly studied. The detailed forensic analysis of exactly when and why scientists had missed the obvious signs of 3i Atlas's artificial nature provided valuable insights into human cognition and scientific methodology. Cognitive psychologists studied the case to understand how experts could overlook clear evidence when it contradicted their operational frameworks. The 3i Atlas case revealed systematic biases in how we process anomalous information, explained Dr. Patricia Williams, a cognitive scientist studying the episode. When experts encounter something unprecedented, they tend to fit it into existing categories rather than creating new ones. The more expert someone is, the more sophisticated their rationalization of anomalies within conventional frameworks. The tendency to explain away anomalies rather than questioning fundamental assumptions had deep evolutionary roots. Human brains were optimized for pattern recognition and efficiency, which meant relying on established categories rather than constantly reconsidering basic assumptions. This cognitive architecture served humanity well in most situations, but could create blind spots when confronting genuinely unprecedented phenomena. Evolution didn't prepare us for first contact with alien intelligence, Dr. Williams continued. Our brains developed in environments where unusual objects were almost always natural phenomena with familiar explanations. The assumption of naturalness was adaptive for 99.99% of human history. 3i Atlas represented the 0.01% case where that assumption was catastrophically wrong. The educational systems that emerged after the 3i Atlas revelation incorporated explicit training in recognizing and overcoming cognitive biases. Students learned about confirmation bias, the availability heuristic, and anchoring effects through the lens of humanity's failure to recognize the probe's artificial nature. We teach students that expertise can create intellectual blind spots, explained an educator developing the curriculum. Being highly knowledgeable in a field provides powerful analytical tools, but it can also make you less likely to question fundamental assumptions that fall outside conventional frameworks. The solution is cultivating intellectual humility alongside expertise. The interdisciplinary collaboration that had ultimately revealed 3i Atlas's true nature became a model for how science should approach unprecedented phenomena. Dr. Rodriguez's background in spacecraft thermal management had given her the perspective to recognize what comet specialists had missed. The synthesis of insights from multiple fields had been essential for breaking through the natural explanation framework. No single discipline could have solved this puzzle alone, Dr. Peterson reflected. We needed the fresh perspective that comes from bringing diverse expertise together. The lesson is that when confronting something truly unprecedented, we need to actively seek input from fields that normally wouldn't be involved. The organizational structures for studying anomalous space objects were reformed to ensure interdisciplinary involvement from the beginning, rather than as an afterthought. Discovery teams now routinely included spacecraft engineers, artificial intelligence experts, and communication specialists, alongside traditional astronomers and planetary scientists. The funding structures for space science were also modified to support rapid response capabilities. The delay between recognizing 3I Atlas's artificial nature and mounting effective communication and protection efforts had been partly due to lack of resources for urgent unplanned activities. New funding mechanisms allowed immediate activation of emergency programs without lengthy approval processes. International cooperation reached new levels as nations recognized that encounters with interstellar visitors transcended national interests and required coordinated global responses. The success of the rapid international mobilization after Dr. Rodriguez's discovery demonstrated what could be achieved when political barriers were temporarily set aside. 3I Atlas gave us a glimpse of what humanity could accomplish with true global cooperation, noted a diplomat involved in the international coordination. Nations that normally competed or even opposed each other worked together seamlessly when faced with alien contact. The challenge is maintaining that spirit of cooperation for less dramatic but equally important challenges. The legal and ethical frameworks for interacting with alien artifacts evolved rapidly after the 3I Atlas experience. Questions about ownership of recovered fragments, intellectual property rights for technologies derived from alien engineering, and responsibility for protecting visiting probes all required new international agreements. The treaties that emerged established that alien artifacts were common heritage of humanity rather than resources to be claimed by individual nations or corporations. Any knowledge or technology derived from interstellar visitors would be shared globally, with implementations managed through international coordination to ensure equitable benefits. We decided that gifts from extinct civilizations belong to all of humanity, Dr. Peterson explained. No nation or corporation could claim exclusive rights to alien technology. We were all inheritors of the ancient civilization's legacy, and we all had responsibility for honoring their gift by using it wisely. The question of whether humanity had obligations to the extinct civilization that created 3I Atlas generated philosophical debates that continued years after the probe's destruction. If ancient benefactors had given freely to help emerging species, did recipients have duties to preserve that legacy and eventually extend it to future civilizations? We're part of an ethical chain extending across deep time, argued one philosopher. The ancient civilization invested resources in helping species they would never meet. The appropriate response is to eventually do the same, to create our own knowledge-sharing systems for civilizations that will emerge millions of years after humanity. The concept of paying forward cosmic generosity across geological timescales provided a new framework for thinking about humanity's long-term purpose and responsibilities. Rather than focusing solely on immediate survival and prosperity, humans began considering their potential role as contributors to galactic-scale knowledge networks. 3I Atlas showed us that intelligence can transcend the limitations of individual civilizations, Dr. Chen reflected. The probe's creators knew they were ending, but they ensured their accumulated wisdom would survive through their knowledge network. we have an opportunity and perhaps an obligation to do the same. The technical challenges of creating knowledge-sharing probes that could operate for millions of years drove research in multiple fields. Materials scientists studied the alien alloys and ceramics that had enabled 3I Atlas's longevity. Power system engineers analyzed the vacuum energy extraction mechanisms. Information specialists examined the data storage systems that had preserved information across deep time. Building something that will last millions of years is fundamentally different from normal engineering, explained Dr. Thompson. Every component must be designed for extreme longevity. Systems must be self-healing or redundant enough to survive countless failures. The engineering philosophy requires thinking about timescales that exceed human comprehension. The recovered fragments of 3I Atlas provided both inspiration and practical knowledge for developing ultra-long-duration spacecraft. Even partially damaged components revealed engineering principles and manufacturing techniques that could be adapted for human applications. Some of the simpler technologies derived from 3I Atlas fragments were implemented within years of recovery. Advanced materials with unprecedented resistance to radiation damage found applications in spacecraft and nuclear facilities. Energy storage systems inspired by the probe's power management enabled improvements in terrestrial electrical grids. More exotic technologies would require decades or centuries of development before human engineering could replicate them. The vacuum energy extraction systems operated on quantum mechanical principles that were barely understood by human physics. The matter-antimatter propulsion systems required containment technologies and control mechanisms far beyond current capabilities. "We're like medieval craftsmen studying a computer," Dr. Foster observed. "We can see that it works, we can identify some components and their functions, but truly, understanding and replicating the technology requires advancing our entire scientific framework. The gap between our capabilities and theirs is humbling." The humility created by encountering technology from a civilization millions of years more advanced provided valuable perspective on humanity's place in cosmic history. Humans were technological infants on galactic timescales, barely beginning to explore space when civilizations like the one that created 3I Atlas had been traversing the galaxy for eons. Meeting 3I Atlas was like a child encountering an adult's library, Dr. Peterson analogized. We could see the books, we could puzzle out some of the simpler content, but truly comprehending the full depth of knowledge would require growing up first. The probe was an invitation to keep learning and developing until we could fully appreciate what was being offered. The psychological impact of confirming that humanity was not the most advanced intelligence, not even close, affected different people in different ways. Some experienced what psychologists termed cosmic insignificance anxiety, feeling diminished by the realization that human achievements were primitive compared to ancient alien civilizations. Others experienced cosmic inspiration, feeling excited by the demonstration that intelligence could achieve such remarkable capabilities, and motivated to contribute to humanity's continued advancement. The existence proof that intelligence could create technologies lasting millions of years suggested that human potential might be far greater than commonly imagined. "The key is framing," explained Dr. Sarah Williams, a psychologist studying human responses to the alien contact. People who focus on how much more advanced the ancient civilization was tend to feel inadequate. People who focus on the fact that they started from similar origins and achieved greatness through persistent development tend to feel inspired. Both perspectives are valid, but the inspirational framing is more psychologically healthy and motivating. Educational and cultural institutions work to promote the inspirational framing while acknowledging the humbling reality of humanity's current limitations. The message emphasized that every advanced civilization had started as primitive tool users and had gradually developed capabilities through accumulated knowledge and sustained effort. The ancient civilization wasn't born advanced, educators emphasized. They developed over millions of years through the same process of scientific discovery, technological innovation, and knowledge accumulation that humanity is now pursuing. 3i Atlas represents what we could eventually become if we maintain our commitment to learning and growth. The multi-generational timescales required for achieving technological parity with the ancient civilization created challenges for maintaining social commitment and motivation. Human political and economic systems operated on much shorter timescales, making it difficult to sustain projects that would require centuries or millennia to complete. We need to develop new institutional structures that can maintain focus across multiple human lifetimes, argued social scientists studying long-term planning. The probe network was created by a civilization that thought in terms of millions of years. We need to learn to plan and execute projects on similar timescales if we want to eventually contribute to galactic knowledge networks. Some proposed solutions involved creating endowments and institutions specifically designed for ultra-long-term projects. Others suggested that artificial intelligence systems with continuity across human generations could maintain multi-century projects that would be difficult for biological humans to sustain. We might need to create AI successors to carry forward projects that exceed human lifespans, Dr. Chen suggested. Just as the ancient civilization created 3i Atlas to outlive them and fulfill missions across millions of years, we might need to create intelligent systems that can maintain focus on ultra-long-term goals, while humanity goes through countless political and social changes. The irony that humanity might need to create artificial intelligence, similar to 3i Atlas, in order to eventually contribute to the knowledge network that created the probe was not lost on researchers. The ancient civilization had apparently solved this problem millions of years ago, and humanity was now following similar developmental pathways. As 2027 approached, the second anniversary of 3i Atlas's discovery, humanity had established a comprehensive understanding of what had occurred and why. The probe had been artificial from the beginning, sent by an ancient civilization to share knowledge with emerging species. Humanity had failed to recognize this truth for crucial weeks due to cognitive biases and assumption-locked thinking. The delay had cost precious communication time and had prevented development of protection strategies that might have saved the probe from destruction. The brief dialogue that had been achieved provided valuable information, but represented only a fraction of what 3i Atlas had been attempting to share. We failed the test that 3i Atlas represented, Dr. Rodriguez reflected during the anniversary commemoration. The probe was offering us knowledge and membership in a galactic community, but we were too locked into conventional thinking to recognize the opportunity until it was almost gone. This failure has shaped everything we've done since: our protocols, our technologies, our attitudes toward the unexpected. The legacy of 3i Atlas extended far beyond the technical knowledge extracted from its fragments. The probe had fundamentally altered humanity's relationship with the cosmos and our understanding of our place in it. We had learned that we were not alone, that ancient intelligences had existed and had cared about emerging species, and that the galaxy contained networks of knowledge and connection spanning deep time. The realization that we had almost completely missed this revelation due to cognitive rigidity and assumption-locked thinking provided crucial lessons about intellectual humility and the importance of questioning fundamental assumptions when confronted with the unprecedented. 3i Atlas taught us that expertise without humility is dangerous, Dr. Peterson summarized. We were so confident in our natural explanation framework that we ignored or rationalized away clear evidence of artificiality. The lesson is that when something truly unprecedented appears, we need to actively question our assumptions rather than forcing new phenomena into old categories. The educational programs, institutional reforms, and technological developments that emerged from the 3i Atlas experience ensured that humanity would be better prepared for future encounters. The successful protection of 5i Voyager years later validated the changes, demonstrating that the lessons had been learned and applied effectively. But the question remained: what additional knowledge had been lost when 3i Atlas was destroyed? What technologies, insights, and wisdom had the probe been carrying that humanity would now need centuries or millennia to develop independently? The incomplete data recovery from the fragments provided tantalizing glimpses of what might have been fully received if recognition had come sooner. We'll never know exactly what we lost, Dr. Chen acknowledged. The probe's full database contained information that could have transformed human civilization in ways we can barely imagine. We received fragments, enough to confirm the magnitude of what was being offered, but not enough to fully benefit from the ancient civilization's gift. That's the price of our failure to recognize truth when it first appeared. The price was paid not just by the generation that encountered 3i Atlas, but by all future generations that would need to develop capabilities independently that could have been received as gifts. The delay in human advancement caused by missing the probe's full message would compound over centuries, potentially affecting humanity's ability to participate in galactic civilization for millennia. Yet the partial success, recognizing the truth before complete loss of contact, establishing dialogue however brief, and recovering some fragments with intact data, prevented total failure. Humanity had learned enough from 3i Atlas to recognize future probes, protect them, and communicate effectively. The ancient civilization's backup strategy of sending multiple probes ensured that what was missed from 3i Atlas could be received from subsequent visitors. The ancient civilization understood that some probes would be lost or misunderstood, Dr. Peterson noted. They designed their network with redundancy, sending multiple messengers to each promising stellar system. They anticipated that emerging civilizations would make mistakes and miss opportunities. The gift was designed to be resilient enough to succeed despite our failures. The resilience of the ancient civilization strategy demonstrated sophisticated understanding of how intelligence developed and what challenges emerging species faced. They had apparently encountered numerous civilizations at various developmental stages during their millions of years of galactic exploration and had refined their approach based on extensive experience. We're benefiting from millions of years of refined first contact protocols, Dr. Chen explained. The ancient civilization learned through countless encounters what worked and what didn't. They designed 3i Atlas and its siblings to maximize the chances of successful contact despite whatever mistakes recipient species might make. We're receiving not just their knowledge, but their wisdom about how to share knowledge effectively. The wisdom embedded in the probe design extended beyond technical specifications to include psychological and social insights about how emerging intelligences responded to cosmic contact. The probes were programmed to adapt their communication strategies based on recipient responses, gradually building complexity in ways that matched the developmental level of species they encountered. 3i Atlas was teaching as much as transmitting, Dr. Rodriguez observed. The probe didn't just dump information indiscriminately, it assessed our responses, adapted its transmissions to our comprehension level, and guided us toward understanding concepts in appropriate sequence. Even in our failure to recognize it promptly, the probe was patiently working to establish effective communication. The patience of the probe, continuing to transmit even as it was being destroyed, still attempting to complete its mission in its final moments, demonstrated the dedication that its creators had built into their knowledge-sharing system. The ancient civilization had apparently considered their mission to help emerging species so important that they engineered persistence and resilience at every level. As humanity continued to study the fragments, implement derived technologies, and prepare for future encounters, the memory of 3I Atlas remained central to scientific and cultural consciousness. The probe represented both a tragedy of missed opportunity and a triumph of eventual recognition. It embodied both human failure to think beyond assumptions and human capacity to learn from mistakes. Memorial installations were established at major observatories and research institutions featuring recovered fragments and artistic representations of the probe. These memorials served as reminders of the importance of intellectual humility, the dangers of assumption-locked thinking, and the magnificent opportunities that await when humans dare to question conventional wisdom. We remember 3I Atlas not just for what it was, but for what it taught us about ourselves, Dr. Peterson reflected during the dedication of a major memorial. The probe revealed our limitations and our potential, our blind spots, and our capacity for growth. Every time we look at these fragments, we're reminded to question our assumptions and stay open to possibilities that transcend conventional frameworks. The fragments themselves, pieces of alien engineering scattered throughout the solar system and preserved in research facilities on Earth, served as tangible connections to the ancient civilization and their mission. Each piece represented accumulated knowledge and generous intent spanning millions of years and countless light years of space. Students visiting the memorials were encouraged to touch actual fragments that had traveled between stars, to feel the physical reality of alien technology and the ancient wisdom it represented. The tactile connection helped make the abstract concepts of cosmic timescales and galactic civilizations more immediate and real. When students touch these fragments, they're connecting with something that existed before Earth even had complex life, an educator explained. They're holding evidence that intelligence can create technologies lasting millions of years, and that ancient civilizations cared enough about future species to invest enormous resources in helping them. This tangible connection often transforms abstract ideas into deeply felt understanding. The transformation of understanding from abstract to visceral drove many young people toward careers in science, engineering, and space exploration. The generation growing up with 3I Atlas as part of their formative experiences developed different relationships with cosmic questions than previous generations who had lived in uncertainty about whether humanity was alone. We're the first generation to grow up knowing with certainty that we're part of a galactic community, a student explained. 3I Atlas proved that intelligence has existed throughout the galaxy for millions of years, and that advanced civilizations created systems to help emerging species. This knowledge shapes how we think about humanity's future and our responsibilities to that larger community. The sense of cosmic citizenship that emerged from the 3I Atlas experience influenced human behavior and priorities in subtle but significant ways. Environmental protection gained additional motivation from the understanding that Earth represented one of relatively rare locations where complex life had emerged. The planet wasn't just humanity's home, but a precious biological laboratory that might eventually contribute unique knowledge to galactic networks. International cooperation became easier to achieve when framed as preparation for humanity's eventual role in galactic civilization. Conflicts that had seemed intractable from purely terrestrial perspectives often became more manageable when participants recognized that they were dealing with challenges that any emerging species would face. 3I Atlas gave us perspective, noted a diplomat working on international cooperation agreements. When you're thinking about millions of years and galactic scales, many terrestrial conflicts seem less important. We're all humans trying to survive and develop in a vast universe. The probe reminded us that we're on the same team in the larger cosmic context. The cosmic perspective fostered by 3i Atlas didn't eliminate human conflicts or solve all problems, but it provided a framework that made cooperation more appealing and division less compelling. The knowledge that humanity was being observed and potentially evaluated by the standards of galactic civilization created motivation to demonstrate wisdom and maturity in how we manage terrestrial affairs. As the decades passed and the immediate memory of 3i Atlas's arrival and destruction became historical rather than contemporary, the probe's influence on human civilization remained strong. Technologies derived from its fragments continue to transform daily life. The lessons learned from humanity's initial failure to recognize its artificial nature influenced educational and scientific practice. The memory of brief dialogue with ancient intelligence inspired continued efforts to advance and contribute to galactic knowledge networks. The recovered data from 3i Atlas fragments continued to yield new insights years after initial analysis. As human understanding of physics and engineering advanced, researchers could extract increasingly sophisticated information from the alien artifacts. Concepts that had been incomprehensible during initial examination became clearer as human science progressed toward the levels achieved by the ancient civilization. The fragments are teaching us in layers, Dr. Thompson explained. Initially, we could only understand the most basic aspects. As our knowledge grows, we can comprehend more sophisticated concepts embedded in the same artifacts. It's as if the ancient civilization designed their technology to remain educational across the entire developmental arc of emerging species. The multi-layered educational content demonstrated remarkable pedagogical sophistication. The ancient civilization had apparently understood that emerging species would need to develop gradually, and they had structured their knowledge-sharing systems to provide appropriate information at each developmental stage rather than overwhelming primitive civilizations with concepts they couldn't yet grasp. They were teachers as much as engineers, Dr. Chen reflected. The probe wasn't just a messenger carrying information, it was an educational system designed to guide emerging civilizations through the learning process needed to eventually comprehend and utilize advanced knowledge. Even in its fragmented state, 3i Atlas continues that teaching mission. The continuing education provided by 3i Atlas fragments ensured that the probe's influence would extend far into humanity's future. Each generation of scientists would discover new insights in the same artifacts that previous generations had studied. The ancient technology would remain relevant and valuable for centuries as human understanding gradually approached the levels of the probe's creators. The ultimate legacy of 3i Atlas would be measured not in the immediate knowledge extracted from its fragments, but in the long-term trajectory it set for human civilization. The probe had shown that intelligence could achieve remarkable capabilities, that knowledge could transcend the limitations of individual civilizations, and that the cosmos contained communities of consciousness connected across unimaginable distances and timescales. Humanity's response to that revelation, learning from initial failures, developing better approaches, protecting subsequent visitors, and gradually implementing alien knowledge, demonstrated capacity for growth and adaptation that justified the ancient civilization's investment in their knowledge-sharing network. We're proving ourselves worthy of the gift, Dr. Peterson reflected as he approached retirement after decades of studying 3i Atlas and its successors. We failed the first test, but we learned from that failure and have done better since. The ancient civilization would probably be satisfied with that outcome. They understood that emerging species would make mistakes. What matters is whether we learn from those mistakes and continue to grow. The story of 3i Atlas, from initial misidentification through eventual recognition to ongoing influence, became one of the defining narratives of human civilization's transition from planetary isolation to cosmic participation. The probe represented both humanity's limitations and potential, our tendency toward assumption-locked thinking, and our capacity to overcome those limitations when confronted with truth. Every student learned about the moment Dr. Rodriguez recognized that the thermal signatures didn't match natural comet behavior. Every scientist was taught to question assumptions and consider unlikely possibilities. Every person who looked at the night sky knew that fragments of alien technology orbited above, continuing to share ancient wisdom with anyone patient and humble enough to learn. The probe that had travelled for millions of years carrying messages from extinct civilizations had found an audience willing to listen, learn, and eventually contribute to the eternal conversation of galactic intelligence. The dialogue that began with Dr. Rodriguez's 2:47 a.m. discovery would echo through human history for millennia, shaping civilization's development and inspiring countless individuals to reach toward the stars.